Okay, we're going to solve simultaneous equations. The first way that we'll look at is graphing. Graphing is probably the least accurate. The mathematical ways are more accurate, but graphing has an advantage if you get a visualization of what is going on. I'm going to assume that you already know how to graph a line, but I'll briefly re-explain it as we go through this. But just understand, if you're going to graph two equations looking for the intersection, you want to go ahead and put both equations into slope-intercept form. Y is equal to mx plus b. That means you're going to solve the equation for y if it isn't already. And then you're going to use the slope and the y-intercept, start at the y-intercept, and then the slope to graph the line. Make sure you graph them obviously on the same coordinate plane, and then you look for the intersection points. Okay, so a couple things we'll look at. One is, how do I know an answer is a solution? Okay, so here I have a system of equations, and they're asking, is 2, 8 a solution? In other words, do these two lines cross at the point 2, 8? That means the 2, 8 would satisfy or be true in both equations. So if I substitute 2 and 8 into the first equation, over here, there's the 2 for the x, the 8 for the y. I get 8 is equal to 8, which is true. So that point is on that line. Now, is it on the second line? When I do the same thing for the second equation and put in 2 for x, 8 for y, I get 8 is equal to 11, which is false. So that point is not on that line, therefore it cannot be a solution. Conversely, the second set of equations will work. If we're asking if the point 5, 5 is a solution to both, if I put 5 and 5 in for x and y, I do it over here. In both cases, I do get 5 is equal to 5. So therefore, that is the point of intersection or the solution. Okay, so let's just take a look at graphing. So step one, if I wanted to graph these two equations here, neither of which is in slope-intercept. So what am I going to do? I'm going to put them both into slope-intercept to quickly graph it. So in this case, I have a y. I'm going to subtract 2x to get y by itself. And when I subtract the 2x from both sides, I get y is equal to minus 2x plus 2. Then to graph it, my y-intercept is 2, which is right there. My slope is negative 2, so from that point I go down 2 into the right 1. Negative slope, that means I can go down or to the right, or I go up or go to the left. One direction is negative. And when I connect those 2 points, you can see the green line. The second equation, I'll go ahead and solve for y by first subtracting 4x, which I have here, and then isolate the y by dividing everything by 8. When I do that, I get this. My y-intercept is a negative 1, which is right there. My slope is negative 1 over 2, so I'll go down 1, right 2, and you can see the point of intersection right here is 2, negative 2. If I check that answer as a solution to both of those equations, it will check. I'm going to show you an example of the importance of checking and making sure an answer is correct. When you're graphing by hand, now if you're using software, you're less likely to do this. But this was actually an innocent mistake that I only caught by checking. Okay, so here I have the two equations. I put them both into slope-intercept form. So the first equation, y-intercept is 2, slope is a negative 1. So there's 2. Go down 1, right 1, draw the line. The second equation, I put it in slope-intercept form. I get a plus 10 for the y-intercept. Slope is negative 3, down 3, right 1. I drew the line. Now, I introduced a slight error in both of the graphs. When you're doing it by hand, and so it looked like this was going to intersect right here at 4, negative 3. So let's take a look at what happens when I check that answer. So when I put the values back into the first equation. So -3 for y and a 4 for x, and I do the work, I get 2 is equal to 4, which is false. So that tells me my answer was wrong. The correct answer is actually 4, -2. It would have been up here, but because of a slight error, and it doesn't take much if the lines are kind of far away from your 2 points, it's inaccurate. Again, the software would be better to do this. But you can see why graphing is not the most accurate, exact way to do it. And the last one, both of them are slope-intercept forms, so very simple to graph. 1 y-intercept, slope is 1 up, 1 right, 1. There's the line there. Second one, -3 y-intercept, up 5, 1, 2, 3, 4, 5, to the right 1. There's the intercept right there. And so that's easy to pick off. Our coordinate is going to be 1 for x, 2 for y. Okay. Some special notes that you'll get no solution if the lines are parallel. Okay, parallel lines never cross. So you'll get no solution. If you graph it parallel, they won't intersect at all. And if it ultimately is the same line, these both don't look like the same line initially, but if I divide this second equation by 2, I get exactly the first equation. So those are identical lines. So that would have infinite many solutions. Okay, so that's graphing.